Okay. For example number 2, we have a force is exerted on a half a kilogram object as shown in the graph above. Determine the velocity of the object after the variable force is exerted from 0 meters to 12 meters. All right, so I just chose a small box with a relatively small person pushing it. At the end, we have the boxes moving. All right, and they want to know how fast it's moving. So if we look at this, initially we are assuming that the velocity is 0. So the kinetic energy would be 0. It stays at the same height the whole time, so gravitational potential energy would be 0. Spring potential energy, there is none. At the end, it's moving, so there is kinetic energy. There's no gravitational. It doesn't change height. There's no spring. And internal energy, there's no friction, so we don't have to worry about that. All right, so here we're going to have the work done. And again, on this graph, all right, if we find the area of both those triangles, okay, we can find the net work done. So that first triangle is going to be 1/2 times 6 newtons times 8 meters. The second one will be 1/2 times -3 newtons times 4 meters. All right, so looking at this here, what we ultimately end up getting is we get 24 and a -6. So we have a total work done of 18 joules. That will equal 1/2 mv squared. So 18 joules is 1/2 times 0.5 v squared, 72 v squared. Take the square root. You will end up getting 8.48 meters per second as your final speed.